So in this problem, we need to determine the equation of a parabola such that the vertex and the focus lie on the y-axis at a distance of b and b prime respectively from the origin. Let us begin. We'll try to understand the problem graphically first. For this, we're going to consider the coordinate axis. So here we have the y-axis. Let's say we're going to consider on the y-axis a point which is going to correspond to the vertex of the parabola, and it is at a distance of b units from the origin. That means the coordinates of the vertex is going to be 0, b. There is going to be no x coordinate here because it lies on the y-axis. Then let's say distance of b prime from the origin along the x-axis, we have the coordinates of the focus of the parabola. So the focus is at 0, b prime. So for this particular problem, we'll assume that the parabola is an upward facing parabola. So our goal will be to determine the equation of this particular parabola. Now let's consider another point on the y-axis. Let's say this is the point A, and we are going to consider the coordinates of point A to be 0, a, such that if we draw a line passing through that point A and perpendicular to the y-axis, that line is going to represent the directrix of the parabola. Now, in order to find out the equation of the parabola, there are two information that we need. One is the coordinates of the focus that's available to us, and the other one is the equation of the directrix. Now, our first task will be to find out the equation of the directrix. So here, we know that the point A through which the directrix line is passing is chosen in a very special manner, such that the distance of point A from the vertex is exactly the same as the distance of the focus from the vertex. In other words, we can say that V is the midpoint of the line segment joining point A and point F. So if V is the midpoint of AF, then we can define the coordinates of point V using the midpoint formula. All we have to do is take the x coordinate of point A, so that's 0, add it to the x coordinate of F, so that's 0 as well, divided by 2. So this is going to be the x coordinate of the vertex, and then the y coordinate will be, we'll take the sum of the y coordinate of point A and add it to the y coordinate of point F, that's b prime, divide it by 2. That's going to be the vertex of the coordinates of the vertex B, and this is also equivalent to 0, b. So what we can do, we can equate. This is going to give us 0 is going to be equals to 0. We only have to equate the y coordinate value. So a plus b prime over 2, that will be equals to b. This is going to give us the value of a. So a will be equals to 2 times b minus b prime. The reason we will obtain the value of a, because a is our assumption, but the actual value of a is 2b minus b prime, which means the coordinate of point A is 0, 2b minus b prime. We need the coordinate point through which the directrix line passes. Now we'll also need the information regarding the slope of the directrix line. Now clearly, the directrix line is parallel to the x-axis. So if it is parallel to the x-axis, its slope is going to be 0, and its equation is going to be given by the, let's find out the equation of the directrix. The equation of the directrix will be y equals to b. Y equals to the y coordinate of the point A through which the directrix line passes. So that's point A only, and its value is given by 2b minus b prime. So that means the equation of the directrix is y equals to 2b minus b prime. However, we'll try to write the equation in the general form of a straight line, which is ax plus by plus c equals to 0. So here we don't have any x component, so we can express x as 0 times x. Added to y, then we have plus b prime minus 2b. This will be equals to 0. So this is the equation of the directrix. Now we have all that we need to find out the equation of the parabola. We have the directrix, we have the coordinates of the focus. So let's try to find out the equation of the parabola. So here we are assuming that the horizontal line on which the focus lies is the axis of the symmetry, or axis of symmetry, or the axis of the parabola, and the vertical line is going to represent the directrix line. So here we're going to consider a point P on the plane with the coordinates x, y, such that P is the locus of the parabola. And that meaning, if we join point P and point F and drop a perpendicular from point P on the directrix line such that it meets the directrix at M, then by definition the length of PF must be equals to the perpendicular distance PM. Now PF can be easily obtained by using the distance formula because we have the coordinates of the endpoint. So all we have to do is take the square root. Underneath the square root, we have to take the difference of the x coordinate and add it to the square of the difference of the y coordinate. The difference of the x coordinate will be x minus 0 and the difference of the y coordinate will be y minus b prime. So this will be equals to PM. Now PM is the perpendicular distance. So we'll use the formula for finding out the perpendicular distance of any point from a straight line. So we have to take the absolute value. Then we're going to consider a ratio. Now here we take the coefficient of x, that's 0. 0 will get multiplied with the x coordinate of point P. So we have 0 times x. Added to coefficient of y, so that's 1. 1 gets multiplied to the y coordinate of point P. And then we have the constant term, so that's b prime minus 2b. So added to it will be b prime minus 2b. And this will be divided by the square root of, we have to take the sum of the squares of the coefficient of x and y. So we have 0 squared plus 1 squared. So this will be now square root of x squared plus y minus b prime whole square. That will be equals to the absolute value of y plus b prime minus 2b. And now what we'll do, we're going to take the square on both sides to get x squared plus y minus b prime whole square equals to y plus b prime minus 2b whole square. Okay, let's keep the left hand side as it is. We have x squared plus y minus b prime whole square. However, what we do, we're going to rewrite y plus b prime as y minus b prime. But we're going to add 2b prime to it. So we get 2b prime minus 2b whole square. Fine. Now we have x squared added to y minus b prime whole square. So this will be equals to, we can expand it by using the formula a plus b whole square. This can be treated as a, and the second term will be 2b prime minus 2b. So we get y minus b prime whole square. Added to, we have 2b prime minus 2b whole square plus 2 times y minus b prime multiplied to 2b prime minus 2b. So here we can cancel out y minus b prime whole square from both sides. So x squared will be equals to, so here we can pull out 2 from b prime minus 2b to get 4 times b prime minus b whole square added to, so here also we can pull out, factor out 2 to get 4 multiplied to y minus b prime times b prime minus b. So x squared is going to be equals to 4 times b prime minus b multiplied to b prime minus b plus y minus b prime. So here we can cancel out b prime, and finally we get the equation y squared equals to 4 times b prime minus b times y minus b, and this is going to be the required equation of the parabola.